Hi students, we will move to the next topic from electrostatics. Today we are going to learn about two concepts, two new concepts. After that this chapter is over, then we will move to the problem discussion sessions. Before that, we will just summarize the topic in which we have learned in the last class. Okay. So last couple of classes we have learned about one concept is called solid conducting sphere. Okay, solid conducting sphere. Okay, this is just a summary. You can write down in your notebook as a summary. It's a continuation of the last topic also. Will just summarize to make it clear. Solid conducting sphere, or it is also called hollow conducting sphere. Okay, hollow conducting sphere, or this is also called hollow non-conducting sphere, conducting or non-conducting sphere, or this is also called shell, or this is also called thin shell. If all these situations are coming for you in a question paper, this all are actually mean a same thing in the sense inside it is empty, nothing is filled inside it is completely empty, and charges are present only at the outside, which means charges are present on the outside surface only. Charges are inside, it is empty. Here no charges, q equal to 0. While we are deriving these steps, we have derived a couple of formula. Inside electric field is what, surface electric field is what, and outside electric field is what. So based on this we have a plot, right? Okay, so electric field, there is no electric field while we are deriving this expression. So we told electric field intensity inside of this type of material, inside it is 0. We got E in equal to 0, and we have a formula for surface and we have a formula for outside. So electric field intensity at inside it is equal to 0. Surface we have electric field, then electric fields are reducing. Okay, so electric fields are reducing if you are going away from the surfaces. Electric fields are reducing. E is proportional to 1 by r square times. So electric field at inside will be equal to 0, and electric fields are present only at the surface. This is the point at which the surface, this is outside point. So you can mention it as E out. This is one case. Okay, another case we have learned about solid non-conducting. This is different from this one. That's what I put a demarcation line. Solid non-conducting sphere. Solid non-conducting sphere means the inside it is not empty, inside and surface everywhere it is filled with the charges. So in this case, what is the graph for this one? Electric field intensity with respect to distance. Electric field inside, in case of a solid non-conducting sphere, if you refer my last videos, you can see like electric fields are present inside. Inside it is not 0. Surface it is not 0. Outside also it is not 0. So everywhere electric fields are exist. So electric fields are there and it's going like this. So E is proportional to R will be here. E is proportional to 1 by R square will be here. So these two graphs are very important. You have to look while you are facing a question, you have to look whether this is comes this 4 category or this is comes on this category. Depends upon that you have to pick up the right option. This is very important. If I remember correctly, last year Neet 2019 also this question is coming as one of the question. So there are frequently this question is asking, but remember this is a summary and this is just like a graphical representation. I remember I have plotted this graph for the last video, and here I have plotted in order to not to confuse, not to have any confusions further. These 4 are same graph for this one. This is only the case which is different, and the graph for this one will be this one. This is a summary of the last 2 sessions of video. I put it as a summary. Okay, now in today's sessions we are moving forward. So write down the heading. Electric field intensity due to a electric field intensity E due to a disk. Instead of selling disk means charged disk, we can say. When charge will be there, only electric field will be there, right? So electric field intensity due to a charged disk. Charged disk. Okay. What happened to my pen? Okay. Charged disk. Okay. So let me consider, this is quite easy, but yeah, we'll go ahead. We have a disk like this one. Disk means like this structures. So narrow, small structures like this one. So I can say a disk is made up of small rings. Small rings. We have one ring, two rings, so 1 and 2, 3, 4, 5, etc. Up to infinite number of rings. If I am keeping smaller one, next bigger 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 one. If I am keeping like this one, what will happen? I will get a disk. We know, we have already learnt a formula. You can refer to your notebook. If you are listening to my videos and you are writing the notebooks, you can see electric field intensity due to a ring. Okay, this we have learned. If you have a ring like this and ring radius is r at a distance of x meter from the center, electric field intensity at this point will be equal to, we have written one formula, right? KQX divided by r square plus x square whole power 3 by 2. This formula we already derived. This is for one ring. Here we have how many rings will be there? We cannot able to count it. We don't know it is one ring, two ring. Depends upon the disk size. It may have 10 rings. It may have 15 rings. Enormous number of rings will be there. So what will happen means, in this case, we will take one ring like this. Just one ring. Okay, just one ring. And whose radius is equal to y, and its thickness will be equal to dy. Then the full circle, the full ring, the full disk radius is r. So how we can go from a smaller one to bigger one? Of course, you know that is called derivations part. So we will actually derive. So electric field intensity due to the smaller ring. Okay, so smaller ring. I'm making like this one. For smaller ring in the disk. For smaller ring in the disk, dE will be equal to, tell me, KQ. Okay, so instead of Q will be here, means Q is a full charge for the ring, for the disk. So for a smaller ring, it is dQ and x meter away, which means I am going to find out electric field will be here at a distance of x meter away. Here I am going to find out. So KQX divided by, with respect to this smaller ring, I am going to find. So what will come? R square plus y square raised to 3 by 2. Now y is the smallest radius I have taken. Okay. So now this is a disk. It is a first questions to you. A disk is a two-dimensional structure or a three-dimensional structure. Disk is something like a sheet of paper, right? So it is a two-dimensional structure. If it is two-dimensional, then we have three parameters related with the charges are there. Linear charge density lambda, surface charge density sigma, volume charge density rho. So which factor will come into picture? If it is a surface charge means it's a sheet. Sheet means surface charge density will come into picture. It's not related with volume means cuboid or a solid sphere kind of things only. Solid non-conducting sphere rho will come. If it is a hollow conducting sphere, then sigma will come, because it is a sheet. Here also it is a sheet of charge, so sigma will come into picture. What is sigma? Sigma will be equal to charge per area, general expression, charge per area. In our case, we have a charge called dq. So dq equal to sigma into area. What is the area of this one? Area of this one means 2 pi dy into dy. This is a sheet, right? This is one ring. Okay, this is like this one ring will be here, and this length is y, and whose thickness is called dy. If I cut it and make it a sheet, then it is like this, and whose length will be coming how much? If a circle with a radius r, I cut it with a scissor and keep it like a strip, then what is the length of the strip? 2 pi y, and thickness is dy. So length into breadth is called area. That's what I have written, 2 pi y. Here 2 pi is actually length and dy is actually breadth. Okay. You can consider like if you fold one A4 sheet paper like a circle, you cut it, it is a sheet. You have length, you have breadth. So length into breadth is called area. So I mark it like this one. Now this is for a smaller ring. What I want to do, I am not interested to get for a smaller ring, but I am interested to get for a bigger disk. So ring to disk transformation, where what I need to do, I have to do integration for this dE. So which means I'll do integration from where to where, 0 to r, full radius 0 to r, k into, instead of dq I am substituting this sigma into 2 pi y into dy into x. X is the distance, it is not changing. If it is smaller one, if it is bigger one, always it is from the center. So x is not changing, divided by r square plus y square whole power 3 by 2. This is a formula. Here we have many terms are constant, k, sigma, 2 pi x, all these are constant, which we can take it out of the integrations. And while we are taking all these steps out of the integrations, rest of the factors in the sense, rest of the elements we can integrate it. So let's continue. I have separated E is equal to 0 to r, k into sigma 2 pi y dy x square plus y square whole power 3 by 2. So 0 to 2 pi k sigma 2 pi x common term, take it out of the integration, and this is a factor. Here we need to integrate. So let me consider y will be equal to x tan theta. So dy will be equal to x into sec square theta d theta. Okay. So x dy by d theta integrating with differentiating with respect to theta. So dy by d theta equal to x sec square theta. So dy will be equal to x sec square theta into d theta. We will substitute, these factors will be there. So k into sigma 2 pi x integral 0 to r, and this is become x here y dy. So y dy we have to multiply. What is y? Y will be equal to x tan theta. What is dy will be equal to x sec square theta into d theta whole divided by x square plus y square. So x square is x square itself plus y square. Y means x. So x square tan square theta whole power 3 by 2. Okay. Here if you further simplify, k means 1 by 4 pi epsilon 0. So 1 by 4 pi epsilon 0 multiplied with sigma multiplied with 2 pi multiplied with x. Limit of integration from 0 to r. Here what will come? X square. Okay. Here we have x will be here and x will be here. X square tan theta sec square theta d theta whole divided by, what is 1 plus tan square theta? Sec square theta minus tan square theta equal to 1. 1 plus tan square theta is equal to sec square theta. So it become x square sec square theta whole power 3 by 2. Okay. So we'll continue this part and we have to do some rearrangements over here. So let me clean the board and you can pause the video and you can write down the steps. So here 4 pi and 2 pi get cancelled. What is balance will be here? 1 by 2 epsilon 0. In the numerator sigma x will be here. Sigma x will be here. Integration limit 0 to r. X square and this x all together I am writing x cube. Tan theta sec square theta. So tan theta sec square theta into d theta whole divided by, okay, whole divided by x square sec square theta. So this become x cube, 2 and this 2 cancel, sec square theta 2 get cancelled, it becomes sec cube theta. Okay, x cube get cancels. Sec cube theta and sec cube square will get cancelled. What is balance? Sigma divided by 2 epsilon 0, integration limit 0 to r. Here 1 tan theta will be here and in the denominator sec theta will be here. and which is multiplied with d theta. We'll simplify further. Sigma divided by 2 epsilon 0 integral 0 to r. What is tan theta? Sin theta divided by cos theta. What is sec theta? Sec theta means what? Sec theta means 1 by cos theta. So 1 divided by cos theta multiplied with d theta. So this will go to numerator. So sigma divided by 2 epsilon 0. Cos theta will get cancelled. Integral sin theta d theta, limit of integration from 0 to r. Okay, what is the integral of sin theta? Differentiation of sin theta is cos theta. Integral of sin theta is minus cos theta. So sigma divided by 2 epsilon 0. Integral of sin theta is minus cos theta. Limit of integration is from 0 to r. Okay, 0 to r. So here we have to substitute the limit. So we have y will be there inner ring, and the outer ring we have capital R will be here. So this r square x r and root of s square plus r square we have written for a full disk, but here we are not considering the full disk, we are not reaching the full disk. So we are starting from y. So instead of writing r square will be here, we have to write y square, because r means we already reached the peripheral, we have not reached the peripheral. We have to apply the limit, then only we will reach the peripheral. So instead of writing r, now we are at the inner circle, so y. So if you are taking these lines from here, then it become, instead of x square plus r square, x square plus y square will come. If you are considering this outer line, this outer line like this one, let me make this diagram to be clear. So that is a 2 circle. If you are considering the inner circle, then x, and this is become root of x square plus y square. This become y. If you are considering this line, then it is root of x square plus r square. Now we are at this y circle, y radius circle. This is y and this is capital R. We are not reached at capital R circles. Okay, so let's continue. So minus sigma divided by 2 epsilon 0 into x divided by, we are applying the limit, upper limit minus lower limit, root of 1 by root 2 taken as root x square plus r square minus of, we are substituting 0. So x 0 will substitute become x square. Okay, x and x square become what will come? X square and the root, so 1, so minus of 1. We'll further continue from here. So minus sign, take it into the integration, sigma divided by 2 epsilon 0 1. So 1 minus x divided by root of x square plus r square. This is the equations for electric field intensity due to a disk. Electric field intensity due to a disk and whose radius is r at a distance of x meter away. If you are asking what is electric field intensity, then this is a value of this electric field intensity. Electric field intensity at a distance x meter, not for a ring, this is a disk. Okay, disk will be consist of many rings will be there. So where we started with one ring and we are integrating all over it, and finally we got a disk. This is what is the derivations, and this is the final expression for a disk. Remember this one, not very frequently asking, but it is quite important to remember this expression, sigma by 2 epsilon 0 1 minus x divided by x square plus r square. Now one questions to you, if it is a disk like this, correct? So what is the electric field intensity at the center? At this center means what will be 0? X will be equal to 0. This point is at the center. If x will be equal to 0, what is the electric field intensity at the center of a disk? Sigma divided by 2 times of epsilon 0. This remember. You remember this formula somewhere also? Yes, we have learned this formula. Electric field intensity due to a charged sheet. Okay, sigma divided by 2 epsilon 0. We have already learned in the previous lecture series videos also. Okay, hope you understood this part. Okay, and we'll move to the next concept from electrostatics. So this is quite simple. Okay, and electric field intensity due to a suspended charged particle. Electric field intensity due to a suspended charged particle means what? Suspended means just hanging. So electric field intensity, I am writing electric field intensity due to a charged electric field, not electric field intensity. We can just say like analysis of, we are not going to find out any electric field. Okay, we are using electric field, but we can say analysis of suspended charged particle. Analysis of suspended charged. This is just a concept, nothing else will be there. Based on that, you may get some questions. Just consider, I have a two charged particle whose mass is equal to m and charge is equal to plus q. This is another charge whose mass is m and whose charge will be equal to plus q. So what will happen means, due to this both are positive charges, if you are keeping two positive charges nearby, after some time it will get separated. So two positive charges equally and which are getting separated by a distance of certain distance. So I am measuring this distance, I am considering this distance as d and this length will be equal to L. There are different questions are coming normally from this sessions or this area. For example, they will ask what is the separation distance between these two charged particles. They can ask a question like this one. They may ask what is the length of the string. They can ask like this one. Mostly length will not ask, they will give you in the question, and they will ask what is the charge. What is each of the bob or this suspended charged particle. This is called suspended. Suspended means just hanging, that's a meaning. So suspended charged particle, what is the charge, so that the separation between them is 2 meter or 1 meter or 0.5 meter, like that they will ask, or they will give you the charge. Then they will ask what is the separations between them. So any kind of model of questions will come. For this, the basic concept is like both are positive charges. So I am marking this as charge number 1, charge number 2. So charge number 1 in physics, laws of motion chapter is there. There you are learned about something called a free body diagram. Free body diagram means you are isolating or you are separating each body and you are marking all the forces associated with that body. That is called a free body diagram. So here first steps, always the first step is I am going to do the free body diagram of the first one. Free body diagram. First mass, if I am taking like this one, this will apply one force called mg. And here it is a string. This is a wire string. So wire will apply, or a string will apply something called a tension. Tension is always away from the body like this. And due to this two charged particle, there is an attraction or repulsion. Repulsion, because it is the same charge. So a repulsive force, these charges will never move like this. This will move like this. So there is a force will be here. This force we know K into Q square divided by D square. These are the factors we have to draw with respect to this. Then total cases is like now if it is kept at some charged particle like this, after some time it will move and it will be always like this. After that further it will not move towards right, it will not move towards left. It is in equilibrium position after attaining certain. First you are keeping charges like this, then slowly move and it will attain like this. Then further it will not get moved. So at that point, this is the distance, this is the point we have calculated. Similarly, we can draw the free body diagram of the second body also. So second body I am drawing. So free body diagram of this second body. Second body if you are drawing, so second body will be here. It will also act a force called mg. It will also act a force called k into q square divided by d square. And this will also act, no, tension is not in this direction, right? In this direction. This is the second body. So tension is in this direction. So two things will be here. Okay, based on that you have to find out the force and k square. Here the tension cases for the first body, we know this is a tension. Okay, this is a tension line and here we have a center lines will be here. And if this angle is theta, this angle is theta. Okay, we can consider a small triangle cases will be here. So if we have something like some situations are like this one, then as I told in physics, we can split this as two vectors. Okay, we can split this as two vectors. If this is theta, if this angle is theta, then what will happen? This angle is also called theta. So what is this factor will come? This become t cos theta and opposite side become t sin theta. Opposite angles are equated. If the body is in equilibrium state means it is not moving. In that case, in that case. In an equilibrium condition, you can apply for cases 1 and 2. 1 and 2 both are exactly the same. There is no difference. So for one cases, equilibrium means total force acting on a body equal to 0. Okay, let me say I have a pen. I am pushing this pen can move towards right. If I am pushing from there, pen can move towards left. If both the side I am pushing with the same forces, what will happen? The body will not get further moved. It will be stays there. Okay, which means left side force equal to right side, top force equal to upside. So all the forces are equal means equilibrium. So right here, left here. So to have equilibrium, T sin theta equal to KQ square by D square. Condition number 1. What is another condition? Vertical forces should be equal, which means what? T cos theta equal to mg. Suppose they ask you to find out the value of theta, what you will do? This is the second conditions. You need to get theta. So if you need to get theta, equation number 1 divided by equation number 2, sin theta by cos theta, basic mathematical principle, tan theta. Tan theta equal to kq square by d square whole divided by mg. This is the third conditions. So sometimes they will give you the value of theta. M mass definitely they will give you, so you can multiply it with the g is equal to 10 meter per second square. While you are doing entrance examination question, do not take 9.8. and the charge if they have given, theta is they have given, for example, then d you can find it out, or in some cases d will given, theta will given, m will given, q you have to find out. So any all other parameters will be given except the one you need to be find out. So remember this concept, analysis of a suspended charge particles. This is all about electric field and electric charge part theory sessions. So all the theory sessions as per NCERT textbook I have covered, and as well as I have taken a few topics which are out of little bit of NCERT. For example, the disk cases is not there as such in NCERT textbook. So little bit of topic I have taken from outside. So study the class notes very thoroughly. Okay, this will be helpful for your board examination as well as for entrance examinations. And this is all about the electric field and electric charge. This chapter, NCERT first chapter, is over. Okay, so thank you and have a nice great rest of the day.